Okay, so for this problem, we're going to go through and graph f of x is equal to x to the 3 minus 4x squared minus 7x plus 10. This is a polynomial, so I'm going to use my template for graphing a polynomial. I'm going to post this template for you so that you have access to it, but it's a nice sort of methodical way of going through and making sure you have all the pieces you need to be able to get the most accurate graph that you can. So the first thing that it has us do is it has us work out the degree. So the highest power of x. So the highest power of x here is 3. So let's write that in. The highest power is 3. And it's worth noting that that's an odd number, right? The leading coefficient in this case is +1. It's not really written there, but there's a sort of missing +1. So I'm going to write positive. And if I've got an odd function with a positive leading coefficient, I know it's going to look something like this. I don't know necessarily about all the squiggles. We're going to figure out all those pieces later. But in terms of the end behavior, we know it's going to sort of start from this bottom left. That's quadrant 3. So let me write that in. 3, that's the bottom left. Okay. And it's going to kind of come up and finish over here in the top right. We call that quadrant 1. So again, we already have a lot about the shape just from looking at the degree and the leading coefficient. But let's go on and get some more of the details of what's really going to happen here in the middle. Okay. So to get the y-intercepts, we set x is equal to 0 and solve for y. So I'm going to plug in x is equal to 0 here. So we'll have 0 to the 3 minus 4, 0 squared, minus 7 times 0 plus 10, which simplifies 0, 0, 0, which just gives me 10. Okay, so before I forget, let's go down and plot on that y-intercept at y is equal to 10 onto this graph. So it's not a super accurate graph, but let's say that 10 was there, and let's plot on the y-intercept, just so we don't forget. Okay, now let's jump back down. Okay, it says that it wants us to find the x-intercepts. So x-intercepts set y is equal to 0 and solve for x by factoring. Okay, oops, jumping around here. Okay, back we go. So we're going to set y is equal to 0. So I've got 0 is equal to x to the 3 minus 4x squared minus 7x plus 10. Now, to get this thing to factor is going to be kind of tricky, and different people have different techniques for how they like to do this. Because this is to the power of 3, and because we have a constant here at this end, there's no common factor that we can factor out between all of these. So different people have different techniques. I personally like polynomial long division, so that's what I'm going to use, but I've also seen people use synthetic division, or guessing and checking, whatever sort of method works for you for being able to factor this, but I'm going to go through it my way with polynomial long division. So polynomial long division requires a little bit of guessing, okay? So we're going to have to go through and find some value of x that when we plug it in, it's going to make this thing be 0. And almost always it's going to be something nice like -1 or 1 or 2, right? So let's try 1. Okay, and if I plug in 1, I'd have 1 minus 4 minus 7. So that would give me minus 11 plus 1 is minus 10 plus 10 gives me 0. So I know, let me write this in words so you can see it. So let me write it here. And maybe let's do it in a different color. So if it says x is equal to 1 makes y equal to 0. So that means that x minus 1 is a factor. And once we have one factor, we can go through and do polynomial long division to see sort of what is left over. So I'm going to take my x to the 3 minus 4x squared minus 7x. If it's okay with you, I'm just going to zoom this in so we can actually see what I'm doing here. Okay, so we've got minus 7x, and then, oh, now I've even forgotten what the problem was, plus 10. Okay, and we're going to take that and we're going to divide that by x minus 1. Okay, so the first thing I always do is divide. So x to the 3 divided by x gives me x squared. Then I multiply. X squared times x gives me x to the 3. And x squared times minus x gives me minus x squared. I'm going to do my subtraction. Minus x squared minus 4x squared minus x squared is really like plus x squared. So that leaves me with minus 3x squared, and we'll bring everything down. Okay, then we're going to do this all over again. So we're going to take minus 3x squared, divide it by x. That gives me minus 3x. Then we multiply. Minus 3x times x gives me minus 3x squared, just like we thought it would. And then minus 3x times minus 1 makes this be plus 3x. Then we'll do the subtraction. Minus 3x squared minus 3x squared, that gives me nothing, which is good. And minus 7x minus positive 3 is minus 7 minus 3 gives me minus 10. So I have minus 10x, bring down the plus 10 and do my dividing one last time. So minus 10x divided by x gives me minus 10. Then I multiply. Minus 10 times x gives me minus 10x. Minus 10 times minus 1 makes this plus 10. Oh, thank goodness. So now when I do my subtraction, those are just the same. So I'm left with a remainder of 0. And as long as you've picked this factor here, this x minus 1 properly, you should get a remainder of 0. So what that means is this x to the 3 minus 4x squared minus 7x plus 10, we can rewrite it as this thing times this thing. So if you have another way of sort of breaking that up, let's go over and write that in. Okay, if you have another way of getting this thing to factor, like I said, you're more than welcome to do it. But this is the way I like to do. So I can rewrite this big long cubic polynomial as x minus 1 times x squared minus 3x minus 10. And then what I'm going to hope is that this x squared minus 3x minus 10, that also factors. So I'm looking for two numbers that multiply to give minus 10 and add to give minus 3, and I think there are two. Let's see, it would be minus 5 and plus 2, because minus 5 plus 2 multiplied together gives me minus 10, and added give me minus 3. Okay, so that one took a little bit more work to be able to get my x-intercepts of 1 and 5 and minus 2. It was a bit of a cruel one. It made you really think back to your algebra skills to be able to get that thing to factor. Once we've got our x-intercepts, then we're ready to classify them. So we're looking at the powers on them. And in this case, this isn't going to be a very interesting example because all of these factors are associated with the power of 1, which is odd, right? So because they're odd, all of these ones here, they're going to cross through. So we've got a cross, and a cross. We've got no bounces here. Okay, so that's a fact. All right, so the next thing it says here is we're going to go through and do our number line. We're going to plot on the x-intercepts, so let's do that. And don't forget that you have to put them in the right order, right? Sometimes that's a common mistake. So let's see. So -1 should be the one that's sort of or -2 should be the one that's sort of farthest to the left. That's a cross. And then the next one should be 1. That one's also a cross. And last but not least, 5. So make sure we've got those in the right order. Then from there, we can go through and test values to see whether it gives us positive or negative values. So let's see, let's pick -3. And if I take -3 from this interval and plug it into the factored version, that's my preference, I end up with -3 minus 1, negative. minus 3 minus 5, negative, minus 3 plus 2, negative. So I've got negative times a negative times a negative, which leaves me overall with a negative, which means our function is going to be below the x-axis in this interval. And let's just go up and see. That sort of makes sense here based on this, right? It says it was supposed to start in quadrant 3 in the bottom left. So it sort of makes sense here that it would be negative here in this interval. Now it says it's going to cross through, so my guess is that this will be positive, but let's just double check why. So let's pick some number in between minus 2 and 1. Let's go with 0. So 0 minus 1 is negative, 0 minus 5 is negative, 0 plus 2 is positive. Negative times a positive makes this positive. Perfect. We know it's going to cross through, so go positive to negative. So my guess here is that this is going to be a negative, but let's just verify that that's true. So pick some number in this interval that's your favorite. Let's go with 2 and plug it in. 2 minus 1 is positive. 2 minus 5 is negative. 2 plus 2 is positive. So we've got positive, negative, positive. It gives this a negative. So we were right. And last but not least, if it has to cross through again, it's going to have to be positive. It also needs to be positive. Remember, it was supposed to end. Let's go back up here. It was supposed to end in the top right, right? So it better be positive, but let's just double check just in case. Let's plug in 6. 6 minus 1 is positive. 6 minus 5 is positive. 6 plus 2 is positive. So positive, positive, positive. Whew. All right, so we've done all of that hard work. And it's nice because they all sort of work together. You have multiple ways of sort of checking whether your answer is right. So once we've sort of got those, let's plot these down on our x-axis and try to draw in our sketch. So we've got minus 2. We can plot in, let's put it here. Okay. And 1, let's plot that here. And 5, let's plot that here. It's not a perfect graph, but I tried. Okay, so we're going to use this information here to help us. So we've got it that it's below the x-axis. It's sort of shooting off into this bottom left corner. So I know that it's sort of going to start there. Right? And then from there, it crosses through. Let me scroll up so you can see. It crosses through, becomes positive. Now we better go up and scoop up that y-intercept before we forget. Then it comes back down, right? Crosses through. It's going to go negative, crosses back through 5, and then goes to positive. Now, it's not a pretty graph, but it is sort of the best graph we can do. Let's make this tail a little bit longer so it doesn't look so weird. Let's make this tail go up a little bit farther. There we go. Okay. And again, do I know whether I did this perfectly, right? Like, is 10 actually the maximum there? Or maybe it goes up, you know, a little bit farther and then comes back down through 10. That might be possible. We don't have that information without calculus. Or, you know, how far do we draw this dip down? I don't know, whatever feels right, as long as it's connecting these 2 points and goes all the way down. If you want, you could pick some test values, like, you know, pick 2, plug it into the original function to get the y value. But your teacher is just really going to be looking for that general shape, unless you're in calculus, in which case you're going to use your calculus skills to go through and find this maximum and the minimum here. But for now, that's sort of a good best guess.